So we've looked at statins and we've seen what they do. Now let's move on to the next pharmacological control, and these are bile acid binding resins. So if you remember, bile acids, they allow the bile salts and bile acids allow the absorption of fats, and then bile acids then enter the enterohepatic circulation to repeat the cycle. So let's see what happens. Well, bile acid binding resins, they, as the name suggests, they bind to bile acids, and therefore they're not absorbed back into the enterohepatic circulation. They can't go back to the liver and be secreted again. Instead, they're lost in the feces. So therefore, you'll have a loss of cholesterol and bile acids. Remember, bile acids, bile salts, bile contains bile acids, cholesterol, bile salts. So you'll lose the cholesterol and bile acids. So what effect will that have? Well, if you're losing the bile acids, then the body's going to recognize that you're losing bile acids, so you're going to get increased bile acid synthesis in the liver. Also, if you're losing cholesterol, then the tissues are going to present more LDL receptors. The muscle and the liver is going to have more LDL receptors to take up more cholesterol. So therefore, you're going to get decreased LDLs, similarly to the statins. Same with statins, because that's the ultimate goal, to reduce the LDLs. They're taken up, and rather than 35% effectiveness for the statins, this is 13% effectiveness, so not as effective. And this will result in a 20% decrease in risk of heart disease, compared to the 42% of the statins. Now let's see what the side effects are. Well, the bile acid binding resin itself is unpleasant, so you're going to get dyspepsia, which is nausea, irritability, diarrhea, because it's going to lower the water potential in the gut lumen, so water is going to move in and cause diarrhea. And also, if you're losing bile acids in the stool, you're going to get smelly stools. And another side effect is, because you're losing cholesterol and bile acids, the liver is going to increase the level of triglycerides. The liver is going to make more triglycerides, whereas this doesn't happen with statins. So, as we can see overall, they're not as effective. Bile acid binding resins are not as effective as statins, so therefore you can combine them with statins. And the examples of the bile acid binding resins is cholecystiramine and cholestyramine. Remember, cholangiocarcinoma is bile duct cancer. So cholange, or chol, means it's to do with the bile. Again, chol is to do with the bile. So just to summarize the bile acid binding resins here, so the resins, they also increase the LDL receptors, so increase in uptake of LDLs, but they also increase triglycerides in the body. They're less effective, and the resins can also cause gastrointestinal problems such as nausea and diarrhea. Now the next drug is called ezetimibe. Now what ezetimibe does is it blocks cholesterol transport protein. So therefore it prevents cholesterol absorption from the intestines. And what that does is it results in a 14% drop in LDLs. You can use it with statins for increased effectiveness, because remember, statins increase LDL uptake into muscle and adipose, muscle and liver even. It has no effect on fat-soluble vitamins, which is a advantage, because you're still uptaking the fats and the fat-soluble vitamins. It's just the cholesterol that's not being taken up as much. And it's also more potent than resins. So we can summarize that here. So ezetimibe blocks cholesterol absorption by blocking the cholesterol transporters. It can be used with statins, and it has no effect on vitamin absorption and is more potent than resins. So now looking at fibrates. Now fibrates do two things essentially. First of all, they increase or stimulate lipoprotein lipase. Now if you remember, lipoprotein lipase hydrolyzes the lipoproteins such as triglycerides and very low density lipoproteins. So if you stimulate lipoprotein lipase, it's going to hydrolyze the triglycerides in the lipoproteins result, and VLDLs are lipoproteins, remember, so if you hydrolyze the VLDLs, you're going to result in decreased VLDLs. So that's one advantage. But when you hydrolyze the VLDLs, what happens? Well, you're producing LDLs essentially, aren't you? Which is still bad. So fibrates, what they also do is they increase LDL uptake into muscle. And similarly to statins, this can cause, as a side effect, myositis, which is tender, inflamed muscles. The two examples of fibrates is gemfibrozil and bezafibrate. You can clues in the name really, fibrofibrate. And fibrates, because they hydrolyze the triglycerides and result in decreased VLDLs, which has triglycerides as well as cholesterol esters, they should be used when you have high triglycerides, very high triglycerides, for example. And, well, why would you have high triglycerides? Well, if you think back to the types of hyperlipidemia, you've got primary hyperlipidemia and secondary hyperlipidemia. Primary being genetic, type 2A and 2B, and secondary being metabolic causes such as diabetes and hypothyroidism. The type of hyperlipidemia that causes high triglycerides is type 2B, the genetic primary hyperlipidemia. So if you have type 2B hyperlipidemia and you have high triglycerides, then you would require these fibrates. And we can summarize the function of fibrates here. So fibrates cause reduced VLDLs, which have triglycerides and cholesterol esters, by increasing or stimulating lipoprotein lipase.